Welcome back, ladies and gentlemen. In this video, we are going to find an equation for a perpendicular bisector. So you're going to be able to find this equation by utilizing some things we've talked about in the past. We're going to be focusing on things like midpoints and perpendicular slopes, of course, opposite slopes. Let's dive right on in. We want to write an equation of the perpendicular bisector of the segment with endpoints of the following P and Q. So we want to find the equation for the specific line that will bisect the segment PQ. So let's go ahead and make the segment PQ first and foremost. So P is at -2, +3, so right here. So there's P. And Q is at 4, 1. So we want to go and actually find the perpendicular bisector of this segment right here. Okay, so that's our goal. How do we do it? Well, let's think of what we need. Right? To be a perpendicular bisector, it has to be two things, right? It has to be perpendicular and split it in half. So what are we going to need to know? Well, we're going to have to find the slope of the line that is going to end up being perpendicular to PQ. So let's find the slope of PQ first and then find its opposite reciprocal to go ahead and find the perpendicular slope. So the slope of PQ is equal to change in y over the change in x. So 1 minus 3 over 4, negative makes positive, 4 plus 2. So we get -2 over 6 simplifies to a -1/3. So the slope of this current line that we have is -1/3. I mean, and that makes sense. Down 1 over 1, 2, and 3. Rise over run. So that's the slope. So then the perpendicular slope will be the opposite reciprocal. So we flip it and negate it. So to flip it is 3 over 1, and then negate it is make negative positive. So its slope is just 3. Great. But what else do we need to know? Well, the other thing we need to know is the bisect part of it. Well, what's going to take care of the bisect part of things? And again, I kind of challenge you to pause the video before I answer the question and think of what will incorporate the bisect part of this equation. Well, that's utilizing the midpoint of slope, right? Of line PQ, using the midpoint of PQ. So let's go ahead and find that midpoint of PQ. And this is going to ensure that we actually split it in half. So x1 plus x2 is -2 plus 4 over 2. y1 plus y2 is 3 plus 1 over 2. So that means that you're going to find a midpoint here at -2 plus 4 is -2, right? So -2. I'm sorry, +2. +2. I don't give negative front. 3 plus 1 is 4, and 4 divided by 2 is 2. All right, so we have a 1, 2. So right here, 1, 2 is going to be our midpoint. All right, so how can we utilize this? Well, again, I want to find the equation. Well, what equation specifically? It is the equation that specifically has this slope, 3, and goes through this point, 1, 2. Perpendicular bisector, right? This will make it perpendicular. This will make it a bisector. So think about what we've done in the past. What do we do when we have the slope and we have a point? Point, slope, form, right? Point, slope, form. Just to recap, remember point, slope, form is y minus y1 equals m times x minus x1, where m is your slope and x1 and y1 are the two ordered pairs that you know are going to be on the line. So y minus y1 is 2. Where did I get that 2? Because this is the point that I want on my equation. So slope is 3, and then x minus x1 is 1. Let's go ahead and just put this into slope-intercept form. So we have 3x after I distribute minus 3. And then lastly, I'm going to go ahead and add the 2 on over. I'm going to put it over here to the left. So y will equal 3x, and then -3 plus 2 is a -1. And that will be our slope our y-intercept of the line that is a perpendicular bisector through PQ. Let me recap. Step 1. All right, we found the slope of PQ to go ahead and find out what is the rise and run of PQ. In order to then find the opposite reciprocal slope, because we know we want it to be perpendicular, we had to take care of the bisecting side of things. So we went ahead and we found the midpoint, and that will ensure that it splits it in half, bisected. And then last but not least, we used the slope that we knew, we used the point that we knew, and we threw it into point slope form to go ahead and find the final equation of the perpendicular bisector.